A very good morning to all of you. So today we are going to perform one experiment on the solar cell. So basically in this experiment we will try to estimate the output voltage and the current from the solar cell. So we will connect the solar cell in series. Now you can see that the all the solar cells are connected in series. There is a plus connection and the positive connection is connected to the negative of the solar cell and it is connected to the second solar cell. Then similarly you can have the series connection of the four solar cells. Now this you can take it from the Simulink library browser. So basically this is available in the Simscape, and you can see the color. The color is in blue. So this is called the physical system. So basically we have directly taken the solar cell from the physical system, and the blocks which we have performed previously is about the Simulink. So you need a converter which will convert from Simulink to the physical system converter. So this is the converter which is going to convert the elements which are there in the Simulink to a physical system. So now this solar cell will be requiring the input power in the form of solar radiation. So that radiation we will be giving in the form of the constant block. You can see that all the solar cells are receiving a constant solar radiation of 1000 watt per meter square. Now, to measure the output voltage and the output current, we need a voltmeter and the volt and the ammeter. So, for the voltage measurement in the physical system, you will be having a voltage sensor. Now, similarly, for the current measurement, you will be having a current sensor. So, current sensor is connected in series, whereas the voltage sensor will be connected to the two extreme ends. So now at the load we are having a variable resistor, and we are giving a constant value. It means this is the highest value. By varying the pot of the variable resistor, you can vary the load value. So this is connected. Now again, you can see this is the entire physical system. You need to see your output in the Simulink. So you will be requiring the physical system to the Simulink converter, that is PS to Simulink converter. This is available in the Simscape. You can directly access that thing and drag and drop, and this will appear in this window. So now this is about the solver configuration. Basically, when you are using a physical system, that means that time you will have to use a solver, that is f of x will be equal to 0. So basically, the entire you can say solar cell is modeled in the form of the equations. So the solar cells can be modeled using the two equations. So for solving those equations, you need a solver. And whenever you are using a physical system, that time you will have to take the electrical reference. So this is electrical reference. This is equivalent to your ground. So many things are common to the Simulink. Like in the Simulink, you are having the voltage measurement. So now you are having the voltage sensor. Now in the Simulink, you are having the current measurement. Now you are having the current sensor. You can see that this is the physical system will be colored in blue, whereas the Simulink is colored in the black. So you can just go through it. Now, when you double click on the solar cell, you need to vary some parameter. So basically, two parameters are very much significant in the solar cell. The first one is the open circuit voltage, and the second one is the short circuit current. So basically, in the open circuit, you can see here short circuit current is 7.34. It is always higher than the current which you are feeding it to the load, because load can never be zero. And you can see here, here I have set the open circuit voltage as 3 volt. So I think 3 plus 3 plus 3. So you should be able to get the 12 volt at the output. So now you can see, I think it is near to 12 volt. What is the current value? Just 12 volt is applied onto the resistor. So the current value will be 12 upon 10. I think it is 1.2 ampere. Yeah, it is 1.2 ampere. Yeah, right. This is 1.2 ampere. So you have got the desired result. So in this way, you can perform the solar cell. And now this solar cell will be further. This solar you can say this configuration will be further be given to the boost converter. Like in the boost converter, you can have this voltage from the solar arrangement, and there you can perform the closed loop also. This is all about the solar module arrangement. So you can perform this experiment and try to find out the output voltage and the current and try to view the waveforms in this scope also. Thanks a lot.